Tell me about a time you handled high traffic or load introduction. This is an important behavioral and technical interview question for software developers, backend developers, senior developers, cloud developers, and team leads. Interviewers ask this question to understand how you handle peak traffic, how you identify system bottlenecks, how you improve API performance under load, how you use caching, pagination, and database tuning, how you use queues or asynchronous processing, how you design for scalability and reliability, how you monitor systems during high load periods, how you prevent production incidents. This question is especially important for Java developers, backend developers, Spring Boot developers, full-stack developers, senior software developers, cloud developers, production support developers, team leads, system design interviews. The best way to answer this question is by using the STAR method. STAR means star. S. Situation, explain the background. T. Task. Explain your responsibility. A. Action. Explain what you personally did. R. Result, explain the final outcome. A good interview answer usually spends 10% situation, 10% task, 60% action, 20% result. The most important part is the action section because interviewers want to understand how you analyzed load, what bottlenecks you found, what changes you made, and how you validated the improvement. Question: tell me about a time you handled high traffic or load. Example 1. Handling high traffic on a REST API situation. In one production application, a customer-facing API started slowing down during peak business hours. The API normally responded in under 1 second, but during high traffic, response time increased to more than 10 seconds. Task: I was responsible for identifying the bottleneck and improving the API so it could handle peak traffic more reliably. Action: I started by reviewing monitoring dashboards, API metrics, application logs, and database query timings. I compared normal traffic behavior with peak traffic behavior. I found that the application servers were handling requests, but the database layer was becoming the bottleneck. One query was performing a full table scan on a large table, and the API was also returning more data than the front end actually needed. To improve the system, I made several changes. X. Optimized the SQL query. Added indexes on frequently filtered columns. Selected only required fields. Added pagination for large responses. Added caching for frequently requested reference data. Reduced repeated database calls. Added monitoring for response time and database latency. I also tested the changes with production-like data volume before deployment. Result: the API response time improved from more than 10 seconds to under 2 seconds during peak traffic. Database load decreased. The system handled high traffic more smoothly. And customer complaints related to slowness dropped significantly. Why this answer works? This answer is strong because it shows, high traffic debugging, API performance improvement, database bottleneck analysis, query optimization, caching, pagination, measurable result. Example 2. Using caching to reduce load situation. In one application, a lookup API was called by multiple screens and services. The data did not change often, but every request went to the database. During high traffic, this caused unnecessary database load and slower response times. Task: I was responsible for reducing database load and improving response time without returning stale or incorrect data. Action: I started by analyzing API call frequency and database query volume. I found that the same reference data was requested repeatedly throughout the day. Since the data changed rarely, I proposed adding a caching layer. I designed the caching strategy carefully because I did not want to create stale data issues. The design included cache key standards, time-based expiration, cache eviction after admin updates, fallback to database on cache miss, monitoring for cache hit rate, monitoring for cache miss rate, alerts for cache-related errors. I cached only low-risk reference data first instead of caching everything. I also validated that updated data appeared correctly after cache eviction. Result: database calls for that lookup data dropped significantly. API response time improved during peak usage. The caching pattern was later reused for other read-heavy APIs. Why this answer works? This answer is good because it shows caching strategy, C, load reduction, data freshness awareness, safe rollout, monitoring, reusable architecture pattern. Example 3. Handling load with Kafka and asynchronous processing situation. In one backend system, a user action triggered multiple downstream updates. Initially, everything happened synchronously, so when traffic increased, the main API became slow and sometimes timed out. Task: I was responsible for helping redesign the flow so the system could handle higher load without blocking the user request. Action: I started by mapping the request flow. I identified which actions were required immediately and which downstream updates could happen later. I found that several downstream operations did not need to block the user-facing API. So I helped move those operations to asynchronous processing using Kafka. The new flow was user action. Main service validates and saves core data. Main service publishes event to Kafka. Consumer services process downstream updates asynchronously. To make the flow reliable under high load, I added unique event ID, idempotent consumer logic, retry handling, dead letter queue, consumer lag monitoring, failed message alerts, audit logging, duplicate message handling. I also worked with QA to test high-volume message scenarios, retries, invalid messages, and downstream failures. Result: the user-facing API became faster because it no longer waited for every downstream update. The system handled higher traffic more reliably. Downstream failures no longer blocked the main request and could be retried safely. Why this answer works? This answer is strong because it shows high-load architecture, Kafka, asynchronous processing, decoupling, idempotency, retry handling, dead letter queue, reliability under traffic. Example 4. Handling high traffic with horizontal scaling. In one application, traffic increased significantly during a business campaign. The application experienced higher CPU usage and slower API responses during peak hours. Task: I was responsible for helping the team prepare the application to handle increased traffic safely. Action: I started by reviewing application metrics such as CPU usage, memory usage, response time, error rate, and request volume. I found that the service was mostly stateless, which meant it could scale horizontally. I worked with the team to increase the number of running instances behind a load balancer. Before scaling, I verified that the application did not store user session data locally in memory. I also checked database connection pool settings, thread pool settings, health check configuration, load balancer behavior, logging volume, downstream dependency limits, autoscaling rules. I added monitoring dashboards to track response time, CPU usage, memory usage, and error rate during the high traffic period. Result: the system handled the campaign traffic successfully. API response times remained stable. Horizontal scaling helped distribute the load across multiple instances, and the team gained a repeatable approach for future traffic spikes. Why this answer works? This answer is good because it shows horizontal scaling, stateless service design, load balancer awareness, resource monitoring, production readiness, traffic spike preparation. Example 5. Handling load in a batch processing system situation. A nightly batch job was processing a growing number of records. As data volume increased, the job started taking too long and delayed downstream reports. Task: I was responsible for improving the batch job so it could handle higher data volume within the required processing window. Action: I started by reviewing batch logs, step execution times, database calls, and file processing logic. I found that the job processed records one by one and made repeated database calls inside a loop. This design did not scale well as the number of records increased. To handle the higher load, I redesigned the job to use chunk-based processing. I added configurable chunk size, batch inserts and updates, cached lookup data, reduced database round trips, step-level logging, record-level validation, skip logic for invalid records, restartability support, performance testing with production-like data. I tuned the chunk size carefully, so the job improved speed without using too much memory. Result: the batch job execution time was reduced significantly. Downstream reports were ready earlier. The system could process larger input files more reliably. Why this answer works? This answer is strong because it shows check, batch load handling, chunk processing, database optimization, restartability, memory awareness, production volume testing. Example 6. Handling high traffic on a search API situation. In one application, users frequently used a search feature during peak hours. As the data grew, the search API became slow and placed heavy load on the database. Task: I was responsible for improving the search API so it could handle higher traffic and larger data volume. Action: I started by analyzing search logs, common filters, sort patterns, and database execution plans. I found that the API allowed broad searches and returned large result sets. The query also applied filters late and used inefficient wildcard matching. To improve performance under load, I made the following changes. Added pagination, added maximum page size, applied filters earlier in the query, added indexes on searchable fields, optimized sorting logic, returned only required fields, cached common filter values, added stable ordering using a unique ID, added monitoring for slow searches. I also worked with the front-end team to improve the user experience by encouraging more specific filters. Result: search response time improved significantly. Database load decreased during peak usage. The search feature became more scalable as data volume continued to grow. Why this answer works? This answer is good because it shows search optimization, indexing, pagination, query tuning, API response control, front-end back-end collaboration. Example 7. Handling high load from external API calls. Situation: in one application, our service depended on an external API for verification. During high traffic, external API calls became slow, and our application started experiencing timeouts. Task: I was responsible for improving application stability when the external dependency was slow or overloaded. Action: I started by reviewing timeout logs, API latency metrics, and thread usage. I found that our application was waiting too long for the external API response. During high traffic, many request threads were blocked, waiting for the external service. To improve stability, I updated the integration design. I added C. Shorter timeout configuration. C. Retry only for safe retryable failures. Circuit breaker pattern. C. Fallback response where appropriate. C. Asynchronous processing for non-critical verification. C. Monitoring for external API latency. C. Alerts for timeout spikes. Clear error responses for users. I also made sure retries did not create duplicate processing. Result: the application became more stable during external API slowdowns. Timeout-related failures decreased. The system handled high traffic more gracefully because it no longer allowed one slow dependency to block too many requests. Why this answer works? This answer is strong because it shows check external dependency handling, check timeout management, check circuit breaker, check retry strategy, check async processing. Example 8. Handling traffic spike after a release situation. After a new feature release, traffic to one endpoint increased much more than expected. The endpoint became slow, and monitoring showed an increase in response time and database load. Task: I was responsible for helping stabilize the endpoint quickly, and then improving the design for future load. Action: I first helped with immediate stabilization. I reviewed logs, dashboards, error rates, and database metrics. We found that the endpoint was being called repeatedly by the front end because the page refreshed the same data multiple times. For the short-term fix, I worked with the front-end team to reduce duplicate API calls. Then, I improved the backend by adding caching for frequently requested data, pagination for large responses, query optimization, response DTO cleanup, monitoring for request volume, alerts for response time spikes. I also worked with QA to test the page behavior under repeated user actions. Result: the endpoint became stable after duplicate front-end calls were reduced. Back-end response time improved after caching and query optimization. The team also added request volume monitoring for new feature releases. Why this answer works? This answer is strong because it shows good. Cook, traffic spike handling. Cook, front-end back-end investigation. Cook, immediate stabilization. Cook, back-end optimization. Cook, monitoring improvement. Best short answer version. If you need a short interview answer, you can say, in one production application, a customer-facing API started slowing down during peak business hours. Response time increased from under 1 second to more than 10 seconds. I was responsible for identifying the bottleneck and improving the API so it could handle high traffic more reliably. I reviewed monitoring dashboards, logs, API metrics, and database query timings. I found that the database layer was the main bottleneck. One query was doing a full table scan on a large table, and the API was also returning more data than the front end needed. I optimized the query, added indexes on frequently filtered columns, returned only required fields, added pagination, and cached frequently requested reference data. I also tested the changes with production-like data volume and added monitoring for response time and database latency. As a result, the API response time improved from more than 10 seconds to under 2 seconds during peak traffic. Database load decreased, and the system handled high traffic more smoothly. Common mistakes to avoid. 1. Saying only we scaled the server.
Bad answer.
We increased the server size and handled the traffic. Better answer. Explain the actual bottleneck, what metrics you reviewed, and what design or code changes improved the system. 2. Ignoring database bottlenecks. Bad answer. The app server was slow, so we added more instances. Better answer. I checked database query timing and found the database query was the bottleneck, so we optimized the query and added indexes. 3. No monitoring. Bad answer. The system worked after the fix. Better answer. I monitored response time, error rate, database latency, cache hit rate, and CPU usage after deployment. 4. No load testing. Bad answer. We deployed the fix directly. Better answer. We tested the changes using production-like data and simulated high traffic before deployment. 5. Ignoring downstream dependencies. Bad answer. Our API was optimized. Better answer. I also checked downstream service latency, timeout settings, retry behavior, and circuit breaker configuration. Best practices for answering this question. Check. Use the STAR method. Explain the traffic or load problem clearly. Mention the user or business impact. Show how you measured the load. Identified bottlenecks using logs and metrics. Explain the changes you made. Mention database tuning, caching, pagination, or async processing. Mention testing with production-like volume. Check. Mention monitoring after deployment. Check. And with measurable results. What interviewers are looking for. Interviewers want to see whether you can stay calm under traffic pressure. Analyze load using metrics. Identify bottlenecks. Improve API performance. Optimize database access. Use caching safely. Use queues or Kafka when needed. Design stateless services. Handle downstream failures. Monitor production systems. Prevent repeat issues. For senior roles, they also want to see scalability thinking, architecture trade-offs, capacity planning, production readiness, incident leadership, cross-team collaboration, long-term reliability improvements. Strong words to use in your answer. You can use words like analyzed, measured, optimized, scaled, cached, paginated, tuned, monitored, load tested, stabilized, decoupled, throttled, reduced latency, improved throughput. Example: I analyzed traffic metrics, identified the database bottleneck, optimized the query, added pagination and caching, load tested with production-like data, and monitored response time after deployment. Good, high-traffic topics you can use. Depending on your experience, you can talk about slow API under peak traffic, caching frequently requested data, Kafka for high-volume processing, horizontal scaling, batch job processing large files, search API under heavy load, external API timeout under traffic, front-end duplicate API calls, database connection pool tuning, thread pool tuning, limiting load balancer configuration, autoscaling, circuit breaker, pagination, query optimization, Redis caching, CDN for static content. Final summary. Tell me about a time you handled high traffic or load is an important interview question for backend and senior software developers. The best answer should include, quote, what high traffic issue happened, why it mattered, your responsibility, what metrics you reviewed, what bottleneck you found, what changes you made, how you tested the improvement, how you monitored the system, what result you achieved. Good examples include high traffic REST API, caching to reduce database load, Kafka asynchronous processing, horizontal scaling, batch processing large data, search API optimization, external API timeout handling, traffic spike after release. The strongest answers show performance analysis, scalability thinking, reliability, monitoring, and measurable impact.